here in the pentose phosphate pathway, no ATP gain, no ATP used.
What is the benefit of it if there is
Okay, excellent question. So what is the benefit of, let me answer your question, of doing the pentose phosphate pathway that occurs in all cells? The main goals are to produce an ADPH. Now why we need an ADPH? An ADPH is important for many biosynthesis reactions, such as synthesis of cholesterol require the presence of an ADPH, synthesis of fatty acid require the presence of an ADPH, synthesis of corticosteroid also we need an ADPH. So it is one required for the synthesis of many compounds, mainly lipid, and it's also, Shabab, and I cannot explain why they are, please, if you have a subject, let's discuss it here first, and then I continue my lecture. You either attend or you leave the class. And believe me, I will consider you present. Alright? Okay, so another importance is that we need in our cells to have the reduced glutathione. And this reduced glutathione is obtained because of an enzyme called glutathione reductase that requires the presence of an ADPH. So no NADPH, no reduced glutathione, no NADPH, no synthesis reaction, and also there is another function which it has a bactericidal activity. I will explain it in a minute. Another importance, in addition to the production of an ADPH in the pathway, we have formation of ribose 5-phosphate, which is the sugar of nucleic acid, not only nucleic acid. Yes. Excuse me? Who are you? Are you a student? What do you want?
I want to ask what when attendance.
I don't know. Are you coming here for the attendance?
لا والله جاي احضر بس عشان يكون الجوي يعلق.
I will let you know. I don't know.
معليش.
Okay, and ribose 5-phosphate is also a component of coenzyme that we will study in 2 weeks. I will give you a lecture on vitamins and coenzyme. So, guys, please, you are first year medical student. Do I have to remind you about it? So, this is the pentose phosphate pathway, PPP. As I said, first of all, to make you happy, you don't have to study these reactions, all right? I'll tell you what you need to study. So, as I said, you should know that the pentose phosphate pathway is divided into 2 phases. Phase 1, oxidative reactions, they are irreversible, these are 1 and 2. And phase 2, non-oxidative reactions, which are reversible. We start with reaction 4 until reaction number 7. In the first part, what's happening here in the first part, the first 2 reactions, glucose 6-phosphate is transformed into 6-phosphogluconate, formation of an ADPH, and the enzyme is glucose 6-phosphate dehydrogenase, and then 6-phosphogluconate is transformed into ribose 5-phosphate, formation of an ADPH, because from a 6 carbon we obtain 5 carbons, so there is a decarboxylation reaction here. It is irreversible, and the enzyme is 6-phosphogluconate dehydrogenase. So from these 2 reactions, they are oxidative, they produce an ADPH, and they are not reversible, and they form the oxidative phase of pentose phosphate pathway. Starting from ribose 5-phosphate, we have interconversion between sugar, which means that we obtain one sugar from another sugar. Let's see how. For example, when we start with ribose 5-phosphate, what's the difference between ribose 5-phosphate and ribose 5-phosphate? What's the difference? Excuse me? Structure, what's the difference? Exactly, what is it?
Ribose is the first carbon, and ribose is the second.
Okay, but this is not the chemistry terminology. Let me make the terminology better terminology. Here it is ribose 5-phosphate is an aldose, so we have an aldehyde group here. Whereas here the ribose 5-phosphate is a ketose, so we have a keto ribose or ribose from ribose because it's reversible. What's the name of the enzyme? Isomerase. Excellent. It's an isomerase enzyme here. Okay, now what's the difference between xylulose 5-phosphate and ribulose 5-phosphate? They are what? Epimers. So what do we need to exchange between these two sugars? Epimerase enzyme. Okay, so by isomerase we obtain ribose 5-phosphate, and by epimerase we obtain xylulose 5-phosphate. Okay, xylulose 5-phosphate by epimerase. Now, what are the products that we have now from reaction 3 and 4? What are the products? Ribose and xylulose. These two will act together in the presence of an enzyme called transketolase. And this enzyme requires the presence of a coenzyme called thiamine pyrophosphate derived from B1. It's called TPP. So in the presence again of transketolase, we obtain two other sugars, C2-heptylose 7-phosphate and glyceraldehyde 3-phosphate. You know how we obtain these two sugars? From these two sugars, we have transfer of this group, 2 carbon, from xylulose to ribose. So when you transfer 2 carbon on a 5 carbon sugar, what do you obtain? How many carbon? 5 plus 2? 7. So that's why we obtain C2-heptylose. And then what's remain here is a 3 carbon sugar. What's this 3 carbon sugar? Glyceraldehyde 3-phosphate. So we obtain glyceraldehyde 3-phosphate and C2-heptylose 7-phosphate. And then in the next reaction, we have also transfer from one compound to the other to form erythrose 4-phosphate and fructose 6-phosphate. And then finally, the erythrose with the xylulose, we obtain glyceraldehyde and fructose. What are these products? They are what? The intermediate of glycolysis. So they will enter in the glycolytic pathway. So, in brief, one oxidative phase that leads to the formation of an ADPH to an ADPH, right? Non-oxidative phase, interconversion between sugar that occur in the presence of transketolase enzyme, where we obtain the intermediate of glycolysis. So the aim of pentose phosphate pathway, 1, to give an ADPH, 2, to give intermediate of glycolysis, 3, to give ribose, which is the component of nucleic acids. Okay? Clear? Okay, now let's see it in brief slide. Let's make it more easy for you. So here from glucose to glucose 6-phosphate to fructose, this is the glycolytic pathway, right?
Yeah.
From glucose 6-phosphate to ribose 5-phosphate and the other sugar, this is the pentose phosphate pathway. To an ADPH, the first one in the presence of glucose 6-dehydrogenase, glucose 6-phosphate dehydrogenase, we obtain intermediate that will exchange with the sugar of the glycolytic pathway. So there is a connection between the glycolytic pathway and the pentose phosphate pathway through the intermediate, sugar intermediates. And these sugar intermediates are obtained due to the interconversion between sugar that occur in the presence of transketolase. So transketolase, it is an enzyme that requires the presence of a coenzyme called TPP. T, thiamine, P, pyro, and the other P is pyrophosphate. Now this coenzyme is derived from vitamin B1, which is thiamine. Okay, thiamine is vitamin B1. So we said that pentoses can be made from the glycolytic intermediate without going through the glucose phosphate dehydrogenase reaction, as I showed you in the previous slide. So transketolase, it is an enzyme that requires the presence of thiamine pyrophosphate as a coenzyme. Sugars, we know that they are important for the brain. So transketolase is the only thiamine enzyme in RBC. So what would happen if there is a reduced affinity between transketolase and thiamine pyrophosphate? What do you think will happen? So the interconversion cannot occur, and there are neurological symptoms that will appear, and we will study this disease, which is where the Korsakoff disease. We will study it when we in the chapter of vitamins and coenzyme. I'll talk again about it. So it is a disease, it's a syndrome due to a reduced affinity between the enzyme and the coenzyme. The enzyme is transketolase, and the coenzyme is thiamine pyrophosphate. So because this enzyme is involved in the formation of intermediate of glycolysis, so there's problem in the energy production. So the neurological system is mostly affected, and one of the symptoms of the disease is memory loss. So the enzyme here is not only depend on thiamine pyrophosphate. It's not the only one that depends on thiamine pyrophosphate. We have other enzymes that also require the presence of thiamine pyrophosphate that you have studied before. Pyruvate dehydrogenase, which is the enzyme that converts pyruvate into acetyl-CoA. It requires all these coenzymes, if you still remember. Alpha-ketodehydrogenase is the one of the enzyme of Krebs cycle, also you studied before. And you have an enzyme which is called branch chain into acid dehydrogenase that you will study later in amino acid metabolism. So all these four enzymes require the presence of thiamine pyrophosphate. And where the Korsakoff disease is due to the reduced affinity between the transketolase enzyme and thiamine pyrophosphate. So, why we need NADPH? What is the function of NADPH? So we said that NADPH is obtained by the oxidative reaction of pentose phosphate pathway, and the first enzyme of the pentose, شباب please انتوا تلاتي ورا القديم, please stop it. The glucose 6-phosphate dehydrogenase is the first enzyme of the pentose phosphate pathway, and it is the rate limiting step enzyme. What do you mean by rate limiting step enzyme? So you have a question here, for sure I will ask about this in the exam. It means that it can regulate the pathway through the regulation of this enzyme. But how this enzyme is regulated? It is inhibited by NADPH. What is NADPH for the pathway? It is what? It is the
electron carrier.
No, for the pathway, for pentose phosphate, it is the product. It is the product of the pathway. So what the product will inhibit the first enzyme or the rate limiting enzyme?
The one before.
Feedback inhibition. So when there is increased concentration, you have too much NADPH, so the enzyme glucose 6-phosphate dehydrogenase will be inhibited. So the first enzyme is inhibited. As a result, what will happen when you inhibit the enzyme? Which substrate will accumulate? Glucose 6-phosphate. So and the glucose 6-phosphate will be used for glycolysis. So you will have enough glucose 6-phosphate, so production of energy. Now, the glucose 6-phosphate dehydrogenase is inhibited by accumulation of NADPH, and it is stimulated by the hormone insulin, and it is activated by NADP+, because NADP+, when it accumulates, it means that you have shortage in NADPH. Okay, shortage in NADPH will cause accumulation of NADP+. So NADP+ will activate the pathway, and insulin also will activate the pathway. So let's see the regulation. So from glucose 6-phosphate to 6-phosphoglucanolactone, we have formation of NADPH, and then to ribose 5-phosphate, we have another NADPH here. But the rate limiting enzyme is the one here, which is glucose 6-phosphate dehydrogenase, and accumulation of NADPH will cause the inhibition of glucose 6-phosphate dehydrogenase. Okay, so the enzyme, rate limiting enzyme of the pentose phosphate pathway is glucose 6-phosphate dehydrogenase, and it is inhibited by NADPH. So let's see why we want an ADPH. What is the importance? I mentioned that it is important for the biosynthesis of fatty acid, of steroids, of what else? Of cholesterol. Okay, and then it has also a bactericidal activity in neutrophil, and I will explain what is the activity. And then it is important for the maintenance of reduced glutathione. Why we need reduced glutathione? Because reduced glutathione is an antioxidant. It will remove and protect against the reactive oxygen species. The oxygen that accumulate due to auto-oxidation reaction in the body that are harmful to our cells should be removed by antioxidant. And one of the antioxidants is reduced glutathione. And to have the reduced glutathione, we need an ADPH. So NADPH is important to have the reduced glutathione in order to protect ourselves from the harmful oxygen species. And this role is cell-specific. So let's see how it is cell-specific and talk about the bactericidal activity. Look here in the liver. Glucose 6-phosphate is transformed into 6-phosphogluconate, and we have production through this enzyme of NADPH.